All right, ladies and gentlemen, welcome to the first video of the year. And in this video, we're going to be looking at the new ESSRT. It's going to take me a while to get used to that name. ESSRT, Earth and Space Science Reference Table. Page number 5. Page number 5. So take out your packet, take out your reference table, and turn to page number 5. Page number 5 deals with the life cycle of stars. Life cycle of stars. What you have on your screen right now is a colorful, vibrant version of page number 5. I feel like page number 5, black and white, just seems really boring. I mean, come on. Look at that. That's just really boring. But when you look at the color version, it brings a lot of things to life. So we're going to be using more of the colored version, but I want you to use the information to annotate your reference table as we go along. All right. With that said, let's move to what we have to do in this video. So like I said, these two pictures are very similar in many ways. One is just the colored version, the other is just black and white, and then there's this other little tiny difference that you would notice somewhere around here. In here you would see that from the nebula you have the development of red dwarf stars, and then red dwarf stars ultimately become white dwarfs. All right, so that is missing in the colored version. So just that tiny little difference, but we're gonna deal with that as we proceed. Now, shall we? To make the concept a little more understandable, I want us to think along a straight line, because the what you have in your earth science reference table is more like a circular pattern. So I want us to think in a very straight jacketed manner. So the idea is this, that when stars are being born, stars are born in a nebula. All right, stars are born in a nebula. All right, so inside that nebula is just gas and dust. Gas and dust are inside the nebula. And then the force of gravity begins to collect the gas and the dust until they form a bulge, and then gravity squashes the gas together and it creates a nuclear fusion. And with nuclear fusion comes heat and light and energy. And once heat and light are being emitted, a star has been born. So simply put, the birthplace of all stars is in the nebula. So that's the womb where all stars are given birth to. Now, once a star has been birthed, the star can become an average small star like our sun, which is what we have right on top. Now, if the star is average or small, as it gets older, it's going to become a red giant, which is the next thing. Then from the next giant, that star would live on and ultimately die in a process called the planetary nebula. So the star is just going to collapse on itself and then give out gas and dust again. So that gas and dust will create another nebula, and then ultimately only the center of that star, the core of the star remains, and that core is what you call the white dwarf. All right, so that is the pathway for an average star. However, if after birth the star is massive, the star is large, now that large star will get older and become a red supergiant. Take note of the difference here. The first one is just red giant, all right, while the second one is red supergiant. So there's a difference there. Supergiant, emphasizing the size. Now, when red supergiants are about to die, they do so in a violent explosion. That violent explosion is called a supernova. All right, supernova, that explosion. And then after that explosion, what we have is a neutron star remaining, or a black hole right there. Okay, so that's just the little difference between an average star and a massive star. So with all those piece of information, let's go back to our original slide that looks more like the Earth science reference table. So again, stars are born in a nebula, right there. Okay, so if the star is average, you would observe that the star will become an average star, just like our sun. Our sun is an average star. All right, and then ultimately that star would live on to become an ordinary red giant, and then it's going to die through the planetary nebula process, and then what you have is just the center, the core of it, which is the white dwarf. Now remember, in your earth science reference table page number 5, you have those stars that are not as huge as our star. They're not as huge as the sun. So those kind of stars, they become what you call the red dwarf. So take note of that. Dwarf red dwarf stars, and red dwarf star ultimately dies and become a white dwarf as well. On the other hand, if the star is massive, is humongous, is large, that star immediately becomes a massive star, and then from a massive star it becomes a super giant. All right, a super giant, which is what we have right here. And then the supergiant will die in a violent process known as supernova. And then once the supernova process occurs, what we are left with is a black hole or a neutron star. And then the remnants of the gas and dust goes back to the nebula and the process continues. Observe, if you will, that an average star like our sun takes more time and lives way longer. So you see that their circle is larger and bigger compared to the massive star. The massive star, they live a very short lifespan. All right, they live a very short lifespan. In that manner. So their circle is way smaller. The reason for this is because as a massive star, they burn more fuel, they burn more gas. So it's like a big truck versus a small little car. A small little car would only use their gasoline little in a very little way, while a huge truck consumes a lot of gasoline, right? So that's the difference here. So because it's consuming a lot of gasoline, it's going to run out of gasoline pretty quick and then die out. We're going to dive a little more into all of those details when we look at page number 2, I believe, or page number 4, I believe. All right, let's move further. So now we're back to your Earth Science Reference Table, page number 5. So everything I say here still applies. And the key takeaway here is gravity is what is responsible. Gravity is what is responsible for fusing the gas and dust to form the star in the first place. And then based on the mass of the star, whether it's a massive star or an average star, that would determine the path that the star would follow. An average star would live longer and follow through that path and ultimately become a white dwarf. If it's not up to an average star, which means it's a very small star, those small stars are referred to as red dwarf, and they can live up to 100 billion years. So they live longer because they are very small. While an average star like our sun would live billions of years, all right? While a massive star, on the other hand, would only live for millions of years, a mere million, because it runs out of fuel quickly. All right, so it dies quickly. So it's going to follow a shorter lifespan and then die through the process of supernova. And what we are left with is a black hole or a neutron star. And the process continues again. So this is called a star circle because it's going back to the planetary nebula and then the process repeats itself over and over again. Pretty much that's it. Add as many of this information to your Earth Science reference table because you're going to need it. All right. So we're going to review some quick question and then wrap it up. Question number 1 says, base your answer on the following question on the diagram below, which shows two possible sequences in the life cycle of stars, beginning with their formation from nebular gas cloud in space. Then you have that lovely diagram there. The question says, according to the diagram, the life cycle path followed by a star is determined by the star's initial. So there are two paths for a star to follow here, right? The path of the massive star right there, and then the path of the Earth Sun-like path. Okay, so what would determine whether or not a star would follow the massive star or is going to follow through the average size? Is the mass and size. So our answer here should be A. Easy breezy. All right, let's move on to question number 2. La 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 la. There you have that lovely diagram. Stars like Earth's sun most likely form directly from A, whether it is a star like our sun or a star like all stars are born in a nebula. All stars are born in a nebula. I remember what we said about nebula. Nebula contains dust and gas. And those dust and gas are collected by gravity, and gravity is the one that scorches and fuses them to create nuclear fusion. And once nuclear fusion is taking place, a star begins to give out heat, light, and energy, and then a star is born. So gravity collects the dust and the gas to create that star. And of course, depending on the mass, that star can follow the massive star path, or can follow the average path, or can even follow the lower path, which leads to the red dwarf that we discussed earlier on. Question number 3. La 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 la. There you have a lovely diagram here. Identify the force responsible for the contraction of a nebula, a gas cloud of molecule, to form a protostar. All right, now a protostar is part of what you see in your earth science reference table. Is highlighted right there in the middle. So a protostar is like a baby star. So what it's asking is, what is responsible for contracting, for collecting the gas, all right, for collecting the gas molecule in a nebula? Of course, the answer is gravity. Gravity is what collects the gas and the dust to create nuclear fusion that gives birth to a star. All right, let's move on. 2 more questions and we're done. Based on your answer, la 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 la, then you have that lovely diagram there. So the question says the final stage in the life cycle of most massive star is A. So if a star follows the most massive path, the final stage should end up in a black hole, all right, according to your earth science reference table. So our answer here should be a black hole. Remember, it says final, final. All right, it didn't say intermediate. If that said intermediate, then supergiant would have been our answer. All right, last question. La la la, that diagram. According to the diagram, a star like Earth's sun will eventually. So, what is the ultimate fate of our sun? That's what it's asking. We know our sun is average in size. Our sun is not massive, it's not humongous. So following the diagram itself, or following your earth science reference table, earth's sun's type, or the average size of stars, would just end up being a white dwarf right there. So our answer here should be change into a white dwarf. C. Ladies and gentlemen, that's a wrap. I'll see you guys in the next video.